this morning. Okay, so what type of a graph is this thing? Here. Number 10. According to your blue sheets, what is it? Exponential. Okay, so what I did was I grabbed my blue sheet about exponentials. I just want to put it over here while we work on this. So the first thing you need to know is that exponentials have an asymptote at y equals k. So we're going to say horizontal asymptote at y equals -2. -2 coming from this, from k. And find this graph and make a horizontal asymptote at y equals -2. I always tell students to do that first because if you try to do HK, just HK, it's actually on the asymptote. This is the one where HK is not actually on the graph. It's weird. Okay, so just for a note, what is HK in this problem? Yeah, H equals +1, K equals -2. And if you go to 1, -2 right there, you could see that's not going to be on the curve because the curve doesn't ever touch the asymptote. Okay, so there's a different formula for the locator point, which is H comma K plus A. We have not used this in a while. Really good reminder here. So 1 comma -2 plus 5. 1 comma 3. Do you guys all see where I got the -2 and the 5 from? You can even put A equals 5 up there if you like. Okay, so when I graph this, 1 comma 3 is going to be in the middle of my points. Okay, this is going to take a little bit of brain work for us. Let's start with 2. 2 minus 1 is 1. 2 to the 1 power is 2. Times 5 is 10 minus 2 is 8. Holy shnikes. Okay. 2 to the 3 minus 1 is 4. 4 times 5 is 20. Minus 2 is 18. Okay, this is the part that you're not going to like. Luckily, most of the time you have a graphing calculator or a calculator of any type on you. But we're going to do this. We're going to try to work on this. So 0 minus what? Okay, let's test your knowledge. 0 minus 1, what's that? -1. Okay, here's the moment of truth. Nice. 2 to the -1 is 1/2. Okay, so 5 times 1/2 is 2.5. 2.5 minus 2 is 0.5. Yeah, it's crazy. Okay, but now let's see if Geo can do this one. Okay, -1 minus 1 is -2. What's 2 to the -2? 1/4. Oh man. 5 times 1/4 is 1.25. 1.25 minus 2 is -0.75. Holy crap in the morning, Mrs. Talbot, really? Okay, so that's probably going to be the hardest part of the entire period, just that little bit right there. 2, 8, 3, 18. La-di-da. La-di-da. Where was I? Oh, 0.5, -1. Okay, now you can see the curve, but come along the asymptote here. Don't touch it. Top. Is it okay with you all if we just skip the describing? I just can't. Okay. We know how to describe. Sorry if you wait. If you don't know how to do it, we should do it. Okay, Connor, let's just do it out loud. A equals 5. What's that?
Right over five, right five.
I love you so much. Okay, okay. A is 5. A is 5. He's thinking H. Okay, wait, hold on. Let me help. 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 Okay.
A is like reduced, like factored, right?
Yeah, yeah, yeah.
Like,
Right here, right here, right here.
oh, vertically stretched by a factor of five.
Score. Okay, now H is shift.
Up for left, right, one.
Yes, and K is
Down to.
you were genius. Genius. Okay, now let's move on to number 12. We're good. This? This was just me trying to show you that HK is not on the actual graph, it's on the asymptote. You can take that off if you like it. If you don't like it, I was just trying to show you guys that usually our locator point is on the graph. This with exponentials, it's not. It's just a weird one. Okay. All right. 4 plus 10, 9 minus 3p equals 64. Okay, we're going to do that thing again where I don't show everything. We can do it. Okay, now on the test, the last test, there are several people who combined these front things. That is not proper order of operations. You have to undo the 4. So minus 4 from both sides. There are only a few of you that distributed instead of dividing. Do not ever distribute into an absolute value. You cannot do that. Okay, are you guys okay with me minusing 4 from both sides without showing it and dividing up by 10 on both sides without showing it? Matthew's like, what is this? Okay, now we have 9 minus 3p equals positive 6. 9 minus 3p equals negative 6. Most of the time I show the little plus minus, but I'm trying to save room here. Minus 9 from both sides, so I have negative 3p equals negative 3. P equals 1. Minus 9 from both sides, negative 3p equals negative 15. P equals 5. Closed. Closed. Okay, I'm going to plug in 3. So it's directly between the two dots. You guys can plug in anything you like except for 1 and 5, but I'm going to do 3. And maybe once I do 3, you guys can see why I picked 3. It's just out of pure laziness. Yeah, it's because it makes the middle 0. False again? Sheesh. Oh, look at me doing the imitation of my students. Problem's done. Oh, wait, no, it's not. Oh, Preston, when did you get here? Cool, cool, cool. Don't let me forget to stamp you. Okay, moving on. Find out your 73 axes that you drew for me, please. I'm going to use my colors here. I'm going to see if I can resist the urge to draw the line of reflection every time. I still might draw it every time. It's just too much, too ingrained. Okay, what we're going to do in this problem is we're just going to summarize what inverse is, like just use common sense and see what an inverse would look like for parent graphs. And talk about what the inverse equation would be or the inverse operation, what would undo this. We're not going to graph anything perfectly. These are just going to be sketches today. Okay. First, y equals x squared. The parent graph is just a regular parabola through the origin. Okay, and then what you can do to find the inverse, well, you can think about what undoes the squared, but to draw the inverse, you can turn your paper sideways and just make the same drawing. Does that work every time? We'll see. We'll see. We'll see. Okay, so what is the inverse function of this? So I'm going to accept two answers here. So what undoes the squared? Square root, but we have to remember. Okay, so this is one of your options. What's your other option? This is an advanced question. This is a thinker. X equals y squared. That is the equation for a parent graph of a sleeping parabola. Mrs. Talbot, does that mean I could just write X and Y at different spots on all of these? Technically, yes, but we don't do that for functions. This just happens to be a non-function situation here. Okay, next one, cubic. Okay, what does a cubic look like? This is a really good review. Goes up, flattens out at the origin, goes up again. This is the one that Mrs. Talbot really doesn't like to draw. So I'm going to do my cheat. Okay, notice it's not exact copy this time because it has to be reflected. Yeah. The reason we got away with it with the parabola was because it was symmetric. Okay, so what function, just by common sense, undoes a cubed? Cube root. And do we have to worry about plus or minus on a cube root? No. Because negatives under a cube root actually work. Okay, this is a fun one, but it really hurts my heart. Y equals X. This is the paragraph of a line. There's the original. You should know that from your line of reflection that we draw every time, that that's what that is. However, why does this hurt my heart? Because I'm using flare pens and the line of the reflection's already there. What would the inverse be? It's the same thing, which means that I need to draw red over top of the blue, which is going to ruin my red pen for a little while. I know, I see your faces. Oh, it's so painful. I don't know what happened here. If you can't do it to your pens, I completely understand. Okay. Absolute value is a V shape. Okay, this one, I did not ask you to do an inverse of this at all. And I won't. Because when you turn it on its side, it's going to be a side, which is like a sleeping V, basically. But the inverse of it is requires you to restrict the domain. So what I mean by that is the inverse is going to be plus or minus. Does that make sense to you guys? Like we undo absolute value with plus or minus, right? Okay, so the inverse, first of all, I got to do this again, which is going to be bad. This is a piece of a line y equals x. This is the piece of the line y equals negative x. So the inverse is plus or minus x, which you would expect because that's what undoes absolute value, except the domain has to be x is greater than or equal to 0. It has to only be this side of it. You don't show the whole line. You can sharpen. This is called a domain restriction, and it's just kind of past our math 3 class. But it does exist. It is there. There you go. Okay, now square root of x looks like this. And this is going to have a similar situation to this one. The inverse is that. So what undoes a square root? Yep. Kind of. No, you're not wrong. Hold that thought. X squared. But because you only started with half the parabola, the inverse is only going to be half the parabola. So you've got to do this thing again. Okay, am I going to ask you to do that? Not really. You saw the ones that we were doing. We were doing the cubics, the parabolas, the lines. Those are the ones I'm going to ask you for. Okay, last one, 1 over x. This is a fun one. That's your old hyperbola, which I've drawn really poorly here. That's fine. Last one for number 52. Okay, now turn your paper. This is another one that's its own reflection. Unfortunately, the inverse is exactly the same as the original function, which means that I need to draw the red over top of the blue again. Just the worst part of this whole problem for me. I draw axes all day to not have to ruin my pen. Speak for yourself, Mrs. Talbot. I am. I understand. Does anybody need me just out of sheer confusion need to show them algebraically why this is its own inverse? I'm never going to ask you to do one. Okay. But if you think about it, just put the y over 1 and cross multiply and you get the same thing. Like, anyway. Okay. Any questions about number 52? So these are common graphs and their inverses. Yes.
I just don't understand how like you look at it and you know, like you have to memorize it or.
Well, you should know that a square root undoes a squared. You should know that a cube root undoes a cubed.
But it's just like looking at it, and, like, knowing it, like.
What shape it is, like this stuff you're saying?
What?
Like this stuff you're saying, like,
Yeah.
I don't know, it's supposed to be just that it gets in your brain over time. That would be the hope.
I'll learn it.
Okay. And this is actually the end of the lesson here, once you get this set up. Yep. One more axis. I know. I'm a jerk. I am a jerk. Oh, I like my joke today though. It's actually good this time. But I can't show it to you till the end because it won't make sense. Like, what is that thing there that I just wrote? It looks weird, Mrs. Talbot. Also, why does my screen look like the opening scene from Star Wars? Do you know what I mean by that? You know, like at the beginning when it's like in the land far, far away and it's like tilted backward, like a trapezoid?
Yeah.
Doing that. Just pretend you're in Star Wars. It makes everything better. Okay. While you're setting up, I'll just say a couple things. Which one of our parent graphs was missing from the one we did in 52 that we did in the warm-ups today? Yeah.
Exponential.
Nice man. Okay. The whole rest of the chapter is figuring out the inverse of an exponential. And it is so important that we spend the rest of this chapter plus the first half of chapter 7 on it. That's not a bad thing. It's just that it has a lot of math that goes with it, a lot of math. And this is something that is helpful for chemistry, maybe. They have watered down chemistry so hard that I don't really know if you use it anymore, but you were supposed to. We'll see. Okay, so let's start with what we know to do. So taking a look at 53, let's just pretend that this is one of our inverse problems that we were doing the last few days, the last, what, 4 or 5 days in a row. And what is the locator point of this exponential? It's not like all the other ones, if you guys remember. So we just did the warm up, thank goodness. Let's just make a little note over here that the H is 0, K is 0. Well, what's A? What? Okay, excellent question for me to ask you right now. Let's take a look. You guys are like, what? Why is it not 3? Well, A is actually in front of the base, outside of parentheses. If there was going to be an A there, there would be parentheses and it would be in the front. Okay, so we made a little note here. Star Wars again. Okay, so if you remember, the locator point was H comma K plus A. So H comma K plus A. All right, so my middle point is going to be 0, 1. Okay, now let's practice those exponent rules. 3 to the 1 is 3. 3 to the 2 is 9. Okay, see what you can do. 3 to the negative 1 is 1/3. 3 to the negative 2 is 1/9. Good idea, but 3 times 3 is 9. Okay, so let's graph this. -2, 1/9. -1, 1/3. 0, 1. 1, 3, and we're just going to skip 2, 9. It's too far off my little baby graph here. So I'm currently exploring the inverse, figuring out what the inverse is. And I know that, yes.
That's not gonna be on the quiz today, right?
Oh, good Lord, no. You could have done the quiz after class on Monday. Like we did not, we just reviewed again yesterday. There's nothing from today. Like I could have totally given it to you at the end of the period Monday and you would have been fine.
It's quite fine. Some of my scores.
Okay, I'll frame it this way. I taught all of the knowledge that you needed for the quiz by actually last Friday. No, this is just after that. Okay, anyway. So what we're doing now is we're exploring what the inverse of an exponential looks like. And so we know we can make a table from the original and flip it for the inverse table. So right now we're just thinking about what does it look like? What is the inverse of an exponential graph going to look like to us so we know we're doing it right? Okay, now just from what you know about inverses and the line of reflection, does this look about like what you'd expect? So what I'm saying is if I folded it down the line y equals x, would it match up? Am I getting that 45-degree angle reflection? Yes. Okay, but what the heck is it called is the question. And for us, for right now, we're going to use what's called a temporary inverse. And we're just going to switch the x and y. So our temporary inverse is x equals 3 to the y. That is the equation of that graph. The problem is you can't put x equals into your graphing calculator. So we need to do more to figure out how to put it in the graphing calculator. Are you with me so far? All we did was make a table off the exponential. We flipped the table. We can see what it looks like. We know that you flip the x and y in the equation, but we can't use that equation because all of our graphing calculator stuff says y equals. Okay. Now I'm going to show you the ebook. I know it's been a hot minute since I've done that. Okay. 54. Parts A through F below are similar to a puzzle that is more than 2,100 years old. Probably 2,200 since this book was written. Just kidding. That was a joke. Mathematicians first created the puzzle in ancient India in 2nd century BCE. By the way, India does not get nearly enough credit for its the input that they put into mathematics. Okay. More recently, about 700 years ago, Muslim mathematicians created the first tables allowing them to locate answers to this type of puzzle quickly. Tables similar to them appeared in school math books until recently. That's when the calculator started coming out. Yeah. So here are some clues to help you figure out how the puzzle works. Okay, so I want you guys to, in your groups, look at the examples. Try to figure out what's happening and then try to answer the questions A through F and talk about it. Look at the examples. Try to figure out what's happening. Answer the questions. I see people writing. So if that person's in your group and they're writing, ask them what they're doing. Wait. Almost. Listen to Jay. Listen to Jay. Okay. Almost everybody's got the pattern. Now we need the problems at the bottom. Little baby number to the power equals that. Yeah. Little baby number to the power equals that. So what we do is, what we're gonna end up doing, I call it the Diamond Circle, because Mr. Diamond was my mentor teacher, and I watched him teach this unit. And what we did was we drew a little snail arrow around here, so this to the power of this equals this. Yeah. So that's what we're gonna do.
Yeah. I like that.
Yeah, like Gary
Yeah.
or Larry. Or Larry's eyebrows is good. Yeah, A is 4. Yeah, A is 4. Okay. Figure them out.
The problem and the answer?
I just wrote the one number answer.
Oh, that's good.
Yeah. It's just 5.
Yeah,
That's like 125.
what you do for you? Keep that going through this food. Whenever Gio's like famous something, I just want to be his personal assistant. That's all I want in my life. Gio, when you're famous, can I be a personal assistant?
I'll think about it, like if I make that.
I would be an excellent person.
I believe. I want to be a driver, so I don't
What?
I want to be a driver, so.
Oh, like Lincoln Lawyers, right? Yeah. I saw the new season came out, but I haven't started watching, or not yet.
So good.
All right, you guys, here are the answers. No, no.
About a little bit.
So check those 4, 5, 10, 125, 3, 1/2. Okay, remember, half exponents are square roots. Okay, so what I want you guys to do is, now that you figured this out, I want you to draw the guy and encircle this, your first one. We're gonna draw that for days. And yes, it looks like the Amazon arrow is fine. Okay, so you start here at the 5. This is just a little visual representation to help you. 5 to the 2 equals 25. Can you follow that around? 5 to the 2 equals 25. It's a loop to it. Loop, you loop that. And your shoes are looking good. That's a SpongeBob reference. You poor children. You don't know who Sesame Street people are. SpongeBob. I will tell you, the rest of my classes liked my count joke, though. That was good. There were people who knew who the count was. That was exciting. Okay, number 55. We're just going to summarize what we learned. So that's not what I wanted to write. Wanted to write that further away. I got all excited about the count. Okay. All right, so exponentials. The inverse of an exponential temporarily for us was x equals 3 to the y. Okay, what we're going to do is switch this around to make it look like this. So this is your first use of this word. This is called a logarithm. This, when I say log, is called a logarithm. Logarithm is what undoes an exponential. So when I say to you guys, how do I undo an exponential? You're going to say logarithm. I know that's a new word. It's a fun word. But the logarithm inverse is y equals log base 3 of x. Okay, before, this is the last thing you're writing, but before we're done, I just want to say one last thing that helps. The base is 3 in this problem. You guys see the base of the exponent is 3. The base of the exponent is the base of the log. The base of the exponent is the base of the log. That means that whatever the base is there becomes the little baby number here. You don't have to think about anything else. You know it's going to be y equals, because that's what we do. All you have to do is take that number for the base of the exponent and put it in the little baby spot, which is called the base of the log. Okay, so this is the inverse of that. Now, hold on. We're going to add steps to it. So we're going to add like the shift and the A and the whatnot and all that, but not today. This is just a dip your toe in the water of logarithms. And we'll have stuff like x minus 1 plus 2, whatever, all that. But this is just it for today. Oh, yeah. We're going to practice it. We just opened the door today. We did not even step through yet, really. So do you guys remember your blue sheets? Next week, we're going to end up filling in this, which is this very last one, which you've probably been wondering about. So that's where this is going. Okay.